Hello everyone, my name is Nitish Kumar and I am the student of KL University with the CSC Honors and I am the peer mentor of DDI subject with my specialization of cloud computing and I am taking the lecture of an DDI subject data driven artificial intelligence of topic of an hill climbing algorithm in such algorithms. Here we can see hill climbing is a simple hierarchical search that can be used, and this was the process for searching which has state set initial state which the starting algorithm. This is the algorithm of the process which we can here we can see that start to set initial state, set to initial state goal state, and if it was s state, it will goes to stop. Then the some problem is over. If it was not for it was for it was not true, it will expand using successor function and finds the new state. Check which is the best state. It checks the best state to select the state. Such strategy, the choice of state to expand is called such strategy. And hill climbing is a simple arithmetic search algorithm that can be used to find a solution to a optimal problem. It is called a hill climbing because it is a metabolic trails to climb a hill. And these are the measuring of the problem solving performance like completeness, optimality, time complexity, space complexity, and path cost, search space size, number of states explored, and characteristic evaluation. These are some problem solving methods. And search state uniform search strategies. This is the uni-informed, ununiformed, and this is the informed. In informed, we have hill climbing algorithm. This was the local search algorithm, and local search hill climbing of the search strategies. So, constraint satisfaction search. It means we are using in this algorithm backtracking search, forward checking search. Here we can see searching for the solution or to a optimization problem. It is called a hill climbing algorithm. Here how will the hill climbing works? Initial state. The algorithm begins with the initial solution often randomly generated to the given problem and with the neighborhood. It evaluates the neighboring solution of making small incrementation changes to current solution. These changes can be through a movement in the problem space. Evaluation function. Hill climb uses an evaluation functions, also known as heuristic functions, to how good each neighbor solution is. This function assigns a score or a value to each solution based on to close a optimal solution. And here we can see that overview of hill climb algorithm. In the previous slide we taught about only search algorithm to aware of the hill climb. Here we can see the hill climb algorithm. This was the overview. For the basics, hill climb algorithm is a mathematical optimization technique used in artificial intelligence AI. It was used in AI because it was very helpful and it was giving with a less cost also. Objective. The goal is move towards the direction to increase the value in landscape to candidate solution. In solution, it was giving the best solution. To see the previous one, it will gives the optimal solution of the giving. Hill climbing is the relatively straightforward and easy to implement. However, it was some limitations and states. This algorithm iteratively moves towards the neighboring states with higher values. This is the overview of the hill climbing algorithm. We can see the working principles of the hill climb algorithm. There are three types: iterative, termination, selection. And in iteration, they calculates the difference between the current position and the position with the best values. Like it will rotate the problem with some rotations until the best optimal solution will give the value. It will iterate. So for that one. And selection, choose the best neighboring state. If improvement is selection, it will choose the best neighboring. Like if we got in some optimal solution, it will choose in a neighborhood state also for the best selection and termination where no better neighbors can be found. If it was no, if the neighbor was not no better than the we can found reaching a peak value, that was called a termination. And we can see the iteration, selection, termination is the process of the hill climbing. For that process only it will run through the whole hill climbing algorithm. Types of hill climbing algorithms. There are three types: basic hill climbing, steepest ascent hill climbing, stochastic hill climbing. We here we for this basis we can go with the basic hill climbing algorithm. We can neglect the steepest ascent hill climbing and stochastic hill climbing because it was more advanced than the we can observe. And basic hill climbing algorithm, select the first neighborhood state which is better value. We can select the, we already done with the value of optimal solution with a iteration with by using iteration. We can also select the neighborhood state which we can help with the values of to become more advanced. That was called basic hill climbing. Steepest test means examines all, it will conclude the all neighbor states. For that we have to go more process. And stochastic hill climbing means makes a random selection. It makes a random selection. It would not choose optimal solution. It just makes a random selection among the hill climbing mode. So for this one, the steepest asterisk hill climbing and stochastic hill climbing were the advanced, but we can choose the basic hill climbing algorithm. Here we can choose our neighbors state with the better values only, and we can choose the advantages. And I already saw an example I written in this one. Here I taken a 8 puzzle Q sum, and here we can see that it will choose the possibilities by 1 box to 3 boxes, and by the 3 boxes we can choose the optimal solution. With that box there are 3 outcomes. In that one also there are optimal solution. By using the optimal solution we can lastly we can use this one. This was called in backtracking also by similar outcomes. And advantages of using hill climbing algorithm means simplicity, easy to understand, and implementation due to its straightforward approach. Memory efficiency, requirement minor memory, has it evaluates the only concurrent and neighbor states. And quick solution, we can get quick solution from the hill climbing algorithm by using ideal for the problem with a large search space due its a spready nature and simplicity, memory efficiency. And in this we can see in the numerical analysis, the hill climbing algorithm is a mathematical optimization technique which is belongs to the family of local search. And we in previous slide I already tell that one, it was basics of the local search, and it is a iterative algorithm. In the similarities we can see the iterative and termination selection. In that one we are using iterative algorithm that starts with at arbitrary solution to a problem, then attempts to find a better solution by making an incremental change to find the best solution for the given problem. It belongs to the family of local search algorithm. We can see in the last one, where the goal is to find the best solution from a set of possible solutions. In hill climbing, the algorithm starts with an initial solution or iterated some small changes to a order to improve the solution. These changes are based on the heuristic function that evaluates the quality of the solution. The algorithm continues to make these small changes until it reaches the local maximum, meaning that can be future improvement. And there are several variants of hill climbing including steepest, steepest, and we are seeing the three types of hill climbing. First choice hill climbing, and this one, the hill climbing can be useful in a variant of optimization problems such as scheduling, routing, planning, and resource allocation. However, it has some limitations. Here we can see the limitations such as tendency to get stuck in local maxima and lack of diversity in such space. Therefore, it is often combined with other optimization techniques such as generic algorithm as simulating handling to overcome the limitations to improve the search results. And we have some disadvantages of hill climbing algorithm also. Hill climbing can get stuck in local optimal, meaning that it will make the global optimum in the problem. The algorithm is sensitive to choose the initial solution, and the poor initial solution may result in pure final solution. Hill climbing does not explore the search space very truly, which can limit its ability to find the better solution. Features. Features of hill climbing algorithm. Variant of generation and test algorithm uses in greedy approach. We can see greedy approach in our subject, and the greedy is means job sequencing, finding the maximum number of prospect or minimum like knapsack branch and bound. Simple hill climbing algorithm evaluates the initial state. If the goal state, then stops and returns success. Otherwise, makes the initial state has a current state. Loops. Until the solution state is found, or these are no new operations present which is applied to the current state. Select a state that has not been applied to the current state and applying its procedure in new state. Performance. There is the evaluate the new state. If the current state is the goal state, then stop and return success. If it is better than the current state, then make it the current state and proceed future. If it is not better than the current state, then continue in the loop until it is fine. Exit from the function. And this was shown by in the previous like search algorithm. Similarly, this one also, but it was the hill climbing algorithm. Limitations and changing the conclusion. Conclusion of hill climbing algorithm. There are three types of conclusions: enhancement, machine learning, and integration real world optimization. And in enhancement, efforts are underway to address the limitations to hybridization with other algorithms and machine learning integration, fusion with machine learning techniques for a broader problem capacity, and real-world optimization, continued exploration of applications in logistic resource algorithm optimization. And in this one we having state space diagram of the hill climbing. They like a graph of x-axis, y-axis. X-axis denotes to the state space is states or configuration of algorithm marriage, and y-axis denotes the values of objective function corresponding to the particular stage. The best solution we can state space tree by objective function as the maximum goal maximum with the optimal solution. This was called the hill climbing algorithm. Thank you.